So this is the first of 3 videos on the solutions to the Tech Able SAC 2 for Math Methods Semester 1 2020. This video goes to the multiple choice. So let's start from the beginning. Question 1. We have a straight line and we need to find which equation shows that straight line. So you can see it's a positive gradient. You can use rise over run, or to find the gradient, or we can just write down the coordinates that we see, which are 0, -2, and 3, 0, and we can find the gradient now. It's x1, y1, x2, y2, and we can so y2 minus y1 divided by, put that out, a little line there, but then divided by x2 minus x1, and that gives us a gradient of 2/3. Our y-intercept is there, which is -2. So y equals mx plus c. We get y equals mx plus c, which sees the y-intercept, so it's -2. Now obviously none of those answers there correspond to that. So we need to rearrange our equation to find out which option it corresponds to. If we look at all of the options, they all have y on the same side as all the other terms. So I'm just going to take the y to the right hand side. So we get 2/3 x minus 2 minus y equals 0. Still doesn't look like one of the options. So I'm going to I can see the x's here all have not a fraction in front, so I'm going to multiply them, or multiply this whole thing by 3. The reason why I'm multiplying it by 3 is because I want to get rid of that 3 at the bottom, and that will give me 2x minus -2 times 3 gives us -6 minus 3y equals 0. And if you have a look, that corresponds to D. Just written in a different order. Okay, question 2. We'll move a little bit faster. Question 2 is looking at the exact distance between points. So we're using the distance formula, which is x2, point x2, second x2 minus x1 squared plus y2 minus y1 all squared. That's the distance between these 2 points. So that's x1, y1, x2, y2, and then we just sub them in. So our x2 point is 5, our x1 point is -1, so just be careful of the negatives. That says minus -1, all squared, plus y2 is -1 minus y1, which is 5, all squared, and it's really now neatening this up. So -5 plus 1 is 6 squared, plus -1 minus 5 is -6, but that's all squared. Yep. So that gives us square root of 72, which simplifies to 6 root 2. Because the square root of 72 is 36 times 2. So square root of 72 is 36 times 2, so that's why that gives you 6 root 2. So the option is B. Alright, question 3. Alright, what do we have here? We have a quadratic, so x to the power of 2, x squared graph, so a quadratic, where you know the x-intercepts are x equals 2 and x equals 5. So that means that if our x-intercepts are 2 and 5, then it must be x minus 2, x minus 5. And if you're thinking why, if you solve this here, if you take x minus 2 equals 0, you would get x equals 2. If you solved x minus 5 equals 0, you get x equals 5. And you have to put a dilation, take into the fact that there's a dilation. We don't know what the dilation is. We can call it A. And because it's the entire family, A can be positive, A can be negative. So A can be positive, it can be negative, but it cannot be 0. Because if it's 0, then you don't have a quadratic. So that's why it is option, what did I say? That's why it is option D, yes. So it's positive or negative, that's what element of R, but not including 0. So D. Let's move on. Question 4. All right, there's a few ways you can do this. You can find the discriminant, or you could actually just factorize it. So let's have a look. This equation has and asks you how many solutions and what type of solution it is. So let's do it 2 ways. Fastest way I think would be, in this case, would be just to factorize it. So if you factorize it, we get 3x plus 2, 3x minus 1 equals 0. And then we get x equals minus 2/3. If we solve that, and if we solve x minus 1 equals 0, we get x equals 1. So that gives us 2 solutions, because it's 1, 2, and they are rational solutions. Alternatively, you can use the discriminant, b squared minus 4ac, so where a equals 3, b equals minus 1, and c equals negative 2. Okay, and you can sub all that in. Actually, I'll just fix that up. It doesn't look very neat. It's a bit hard to see that. You can sub all that in, and you get the discriminant equals, once you sub it all in, minus 1 squared minus 4 times a times c. You end up getting, that's minus 1 squared is 1, minus 4 times 3 times minus 2 is positive 24, so that equals 25. Now that 25 is greater than 0, so that means it is a perfect square. So 25 is also a perfect square, and your discriminant is positive, so that's why it is 2 solutions, because it's greater than 0, and because 25 is a perfect square, it's rational. So 2 rational solutions. Again, option D. You only needed to do 1 of these. Moving on to question 5. You've got all these different colored pens. The total number of pens is 4 plus 3 plus 5, which is 12. So you need to find the probability that is not red. So having a not red, get my pen working again. Not red is just the total is 12. If we minus 4 blue, if we minus 5 black, we get 9 pens that are not red. But we need to find it in terms of probability. So probability of not red is what we found there. That number 9, that's the number of not red pens, divided by the total, which as we said was 12, because 4 plus 3 plus 5 gives us 12. Now that's not an option because we always express our fractions in the simplest form. That simplifies to 3/4, which is option B. All right, moving down. Question 6. Okay, so now the key with this one is it says they are independent events. So probability of A equals 0.5 and probability of B equals 0.2. Find the probability of A union B. So for independent events, you may recall the probability of A intersection B, not union, intersection B. Drop that off that little bit there. Intersection B equals the probability of A times by the probability of B. So that equals 0.5 times 0.2, and that equals 0.1. But that is not A union B, that is A intersection B. So you still need to find probability of A union B. So probability of, my pen, let me just get it working again. So the probability of A union B, you may recall, is equal to the probability of A plus, plus the probability of B minus the intersection, because you can't count it twice. And now you just double that in. So probability of A we know is 0.5. Probability of B we know is 0.2. Minus the intersection, which you just found before, which was 0.1. And you get 0.6, which is option D. Okay, question 7. All right, so here we have a cubic graph. It has a point of inflection. You can see that by the graph, but you can also see that by all the options that you're given as well. You can clearly see that this here has to be, this point here, this point here has to be positive. Work that out. This point here has to be positive. Didn't disappear. Keeps appearing. Okay. Let's just leave it. And that point there is positive. Out of all the options, they all have either an x value. So for example, in this one here, the for the point of inflection, the x value would be -1. For this one here, for C, the point of inflection, the x value would be +1. This has to be +1. So if we have a look at all of these options, for this to be +1, then the equation must be y equals x minus 1, all cubes. If we have a look at which options, that just gives us C or D, and it is clearly not moved up, it's moved down, so it must be -1. The only option is D, a process of elimination. All right, let's keep going. Okay, question 8. This hopefully was a fairly fast one. So we're looking at A intersection B, so just where they overlap, and there's only 3, so it equals to 3 over the total. Now let's go back here, is equal to 3 over the total. So the total is 4 plus 3 plus 6 plus 2, which is 15. Again, that is 3 over 15 is not an option because we always simplify our fractions, so that gives us 1 over 5. That was B. Okay, let's move on. Question 9. A polynomial is divided by x minus 1, the remainder is 6. So this is using the remainder theorem. So if we sub in, so if we take x minus 1, we solve it, you get x equals to 1. We sub that into this polynomial. So P of 1 should give us the remainder, which is 6. Okay, so let's sub that in, and we'll be able to find, we'll sub in x equals 1, let what we found equal to 6, and we should be able to find what D is. So let's do that. So P of 1, let's move this over here. So P of 1 is, that's 1 cubed plus 2 times 1 squared minus 10 times 1 plus D. That will equal 6. And then if we work that out, so 1, I'll just work it out below. So 1 to the power of 3 is 1, plus 2 times 1 is 2, minus 10 times 1 is minus 10, plus D equals 6. If we rearrange that, we get minus 7 plus D equals 6. So minus 7 plus D equals 6. Therefore, D equals 13, which is option E. Okay, and that's an X there. All right, let's keep moving. Okay, question 10. Question 10 is just seeing if you understand how to graph this. This is a hyperbola. So y, x. Question is, where are the asymptotes? So it's not moved up or down. So you've got one asymptote here